interesting.
Welcome. Give him a big hand, everybody.
Yes. So the year is 1993. Bill Clinton's first presidency. Jurassic Park just hits theaters. And the top hit song of the year is Dream Lover by Mariah Carey. But before copyright kills me, we're here to talk really about the internet. Because another thing that happened in 1993 is, well, a dude, or a sir really, from CERN University called Tim Berners-Lee releases the World Wide Web to the public for free for the first time. And it was something else. I mean, I wasn't there, I was just 3 at the time, but people say it was awesome, and the revolution is actually undeniable. But compared to today's standards, the web was pretty boring. I mean, all it had was just links. I mean, it was web pages and links from web pages to other web pages, and you could browse between them and do it again and again, and that's about it. And the only revolution came 2 years later when the HTML2 specification really came out. And among all its new features, it brought one that changed everything: the form element. You see, up until then, there was no standardized way of sending data back to the server from a web page. And suddenly people could subscribe, update, comment, post, make searches, purchase, everything from a web page. The form turned the web from just a collection of web pages, linked web pages, to an application delivery platform, the most common application delivery platform. But giving users all of these capabilities comes with a big can of worms, like, what about bad actors, scammers, spammers? What about people who are just not very good with the web and, I don't know, make mistakes filling up forms? Well, this is what form validation is for. And in the world of form validation, we usually think about 2 kinds of form validation. We have security form validation, or integrity, that makes sure that the data that gets sent to the server is actually okay to serve and present. And also user experience form validation that makes sure for the user, gives them the confidence that the data will be accepted by the server when it gets sent. Now, we've all been there. Both as developers, I mean, most of us writing front-end code have written some sort of form validation, probably. But also as users, we've been to places where forms are not as good as we expect them to be. I mean, typing in one character in one input field and suddenly all the other input fields become red because they have some error inside but you didn't touch them yet, or the submit form will just not get enabled even though you fixed all the errors, so what's up with that? And the question Barry asked is real. Do forms on the web have to suck? Well, what? Oh. Oh, thank you. Thank you. Now, before I answer that, let me introduce myself. So, I'm Evyatar. I'm a front-end engineer at Meta, and I'm the author of Vest Validations Framework. And I'm also passionate about user experience, API design, framework development, and open source. You can find me on my website, GitHub profile, and I'm also sometimes lurking on Twitter. At me if you want. And I'll tell you a bit about Vest. Vest is a form validations framework that's highly inspired by the syntax and style of unit testing libraries like Mocha or Jest. It takes the syntax, the declarative syntax, and I'll show you later, and uses it for form validation. It's so exciting and so great that even Kent C. Dodds, Kent the Great, said that Vest is interesting. Thank you, Kent. That's all you've got? But more seriously, though, why did I create Vest to begin with? What are the issues we have with form validation? And I'll try briefly. This is a typical form validation. This one is written in React, but it could be really anything. We have like our change handler. Within it, we have some, I don't know, if we're in the username field, do that and set this error. And if we're in the password field, do that. If it's too short, too long, if it's empty. So much code to put inside our feature, and so much bloat, and it's really hard to read. And what if I want to change something? And yeah, of course, I can hide it inside the function, but you're not fooling anyone. It's still there. It's going to be as hard to maintain. I mean, I know it's there. You do? And I think we have 3 main real problems when writing form validations on the web today. One is an inherent lack of structure. you don't really know where to put stuff. Should it be inside our feature? Should it be outside? And also, how should we write the form validation? Is there any syntax? Is there any structure? I'm not sure. Of course, eventually we make it work. We stuck some of it inside our feature, some outside. We write some feature-specific code for it, and a few months later, when we come to maintain it, well, it's really a hassle to work with. I mean, you have to tear everything apart because everything is feature-specific. If you want to add another field you didn't plan on before or make fields depend on one another, yeah, good luck. And the last thing is testing. And why is it important to test form validation or forms in general? Well, forms, and remember this, are the interaction-heavy parts of our apps. This means this is where our users spend the most time clicking, typing, touching, scrolling, and this means that this is where they're most likely to spend more time and face more bugs. And unfortunately, this reason makes it the hardest one to test, because every test we want to make in form validation has to go through some user input simulation. So we have to simulate the user event. And if we have some complex validation, like for fields that depend on one another, yeah, again, good luck. So we don't do it. And, well, as I've said, forms on the web exist since 1995, roughly, April of 1995. And, well, many people have done it before. You probably have too. So it can't be this hard. I mean, can it? Probably there are tens of libraries and frameworks that already deal with it, right? Well, not tens, but 10,000 libraries that deal with form validation. So why is VEST so different? Why VEST is so special? Before I talk about VEST then, let's first examine what kinds of form validation libraries we have actually. And I think there are three types. We can divide them to three types. One, oh, I was supposed to say it here, but one is functional matcher. Functional form validation matchers like is email, is number, longer than, shorter than, is credit card, whatever, which is excellent. I mean, some of them are really top-notch, amazing, great, but they don't solve the problem of structure. They don't care about where I put the stuff. I still have to have all this ugly code inside my feature because they don't care about it. They just give me a boolean if it's okay or not. Second, we have schema validation libraries, and there are many of them, and they are very popular in the past couple of years. And these are excellent if you're on the server, but on the client they have an inherent problem. We have a schema, which means that if I want to work with some user interaction, for example, if I type inside the username field, well, should I go validate the whole schema for it? Probably not. So either I or the framework have to validate everything and filter out the rest, which is a big problem. And also, if I don't do this, or if I just want to have multiple messages or multiple validations for the same field, well, we can do it, but we sorta can't, but we can, and yeah, it's wonky, and you shouldn't do it really on the client. And third, we have like component libraries or UI libraries that work with framework-specific validation, and I don't want to name them because they're actually good, pretty good, but they lock you into a framework. So if I share the validation between multiple apps in my company or want to share it with my server, it's kind of hard. And also these libraries, they give me components, event handlers, references, whatever it is that your framework does. And then what happens is they take some of the control away from me. And if I want to bypass that and get some custom behavior in the future, well, I'm stuck with that library, and it's really, really hard to bypass. So what's my proposed solution? Well, my proposed solution has to answer for all three problems: structure, maintenance, and tests. It has to be separated from our feature code. It has to be really easy to read, really to write, really easy to maintain, and it has to be highly testable because, well, we care about tests. And talking about tests, a couple of years ago, when starting to write unit tests for at work, I came up with this pattern, which is basically the common pattern of unit tests. So we have our unit test in suite. Inside of it, we have a series of tests that tell us exactly what they do and what they test. And inside of it, we have an assertion that some value matches some criteria. Now, let's shift perspective a bit. What if the top scope was our form? Each test would correlate with a specific field, and then each assertion would be the assertion for our values instead of for some function. Well, apparently it works perfectly. And this is what I came up with. So we have our validation suite to which we pass our form data instead of some functions. Inside of it, we have a series of tests. So in this example, username, and this is really similar to unit test, only that we also specify the name of the field that we're validating, and the message, this is the actual message the user will see. And then, well, we have enforce that is very similar to expect, only slight change. From the suite, I'll take the result object. The result object basically contains... What? Oh. Okay. Yeah, that was amazing. Thank you. So const res, I get the result object from my suite.get, and it gives me the most up-to-date result object. And then I'll add my my validation messages from the result object for the username. So messages equals res.getErrors for username. So this is all I have to do, and now I only have to run my validation after I set my state. So I'll run my suite with my next state, so with my form data, and if I type inside username and remove everything, we'll see username is required. I didn't add much to the form, to my feature code, other than that. So let me quickly just add a few more validations, simple validations. So for example, username must be at least 3 characters. Yeah, username longer than 2, right? Yeah, 2. Let's do the same for password. Quickly. Yeah, password. Password is not blank. It must be longer than or equals 5, let's say. Longer than or equals 5 because we have to be secure. So yeah, and now let's connect the password as well to the form because, well, it has to be connected for it to work. And let's do it like this, password. And if I type inside the username field, we see that we get the username must be at least 3 characters, and also we see that password is required because, and this is not a great idea. This is what I was talking against before. I mean, we shouldn't get the validation error for fields we didn't touch yet, right? Right. And this is really, really, really easy to handle. Vest doesn't assume and doesn't know which field you touched because Vest is not connected to React. You could use it with any framework. So all we have to do here, we just have to pass the name of the current field, the name of the current field we're working with, to the suite. And here, all we have to do is take only from Vest and tell Vest, yeah, only validate that. Yeah, I think you should only do that. And now if I type inside the username field, only the username field gets lit up. By the way, with the second error, if I remove, we'll see the first error. And then if I type inside password, we'll see password must be at least 5 characters. And as I type, it gets longer and it disappears. Now I promised you colors before. You saw error is red, success is green, so let's do this. Vest is not a UI framework, but it does come with some UI helpful utilities. So I'll import class names from Vest. I got fat fingers. Okay, and now I'll take const cn equals class names, and cn is basically just a namespace I'm holding, and it returns us a function. And what I do is I take the result object, pass it over to class names, and say, well, when it's valid, give me the success class name, and when it's invalid, give me the error class name. And if it's warning, yeah, we also have warning. Let's do warning. Now let's take class name equals cn with the username field. So give me the classes for the username and also do the same for password. Now if I type inside username, come on. What? Is it? Oh my god. And then it's becoming green, and now if I type inside password, it's becoming green only after it's valid. Cool. What? Okay. Now let's also make sure that the submit button is disabled until we're ready, until everything is valid. So let's do disabled equals res dot valid. Okay, is valid, right? It should be is valid. Yeah. Okay, so now let's refresh. Let me see. Res is valid. No, isn't. Disabled. Let me check that for a second. What? Oh, not is valid. Right. Correct. Not is valid. So now as I type, thank you for that. As I type, it only becomes valid and only becomes enabled after it's valid. Thank you for that. Now, we sometimes have more complex validation logic. For example, what if we want to test that the username doesn't exist on the server? This is really expensive, really, when we do like async validations. And Vest helps us with it. So I created a fetch server call that checks if a user exists on the server. And let's try it. Import does user exist from API, cool. And all you have to do with Vest is just return a promise or run an async test. So this is going to be really, really easy, really simple. Test.username, let's say user already taken. Yeah, sure. And now this function returns a promise, so it's by design an async function. And all we have to do is pass over data.username. And now we first have to tell React, well, display a spinner whenever we type inside the username field, because otherwise we won't even see that. So let's do, we have the spinner state here, and let's say username pending. It should be, yeah, pending equals to username pending. And now all we have to do is, and this is React, this is not even Vest, let's do if current field equals username, no typos, okay. Let's do set username pending to true. All we have to do now, and by the way, if I type inside username, yeah, okay, it's spinning. We only have to tell, well, Vest, whenever you're done validating that username field, go ahead and do whatever I want. So const res, and then I'm taking the actual run of the validation, and let's do res.done, and let's say set username pending to false. What happens now is that if I start typing, and let's refresh, if I start typing, I see the spinner, and then everything is okay. Now let's try a taken username, because I didn't show you anything yet. So let's do admin, because admin is taken. User already taken. Awesome, awesome, really awesome, cool. Now let's try something else. Let's try another one. Okay, perfect, this is okay, and let's delete. And did you see that? I just typed inside username, and we saw the beach ball, even though we already know that username is taken to begin with, because we've already tested it. So let's fix that. Vest gives us a memoization capability. It allows us to specify, well, if the username doesn't change, yeah, just don't run it and use the same validation result we had before. So test.memo, similar to React memo. Okay, and let's do data.username. So as long as data.username doesn't change, it will stay the same. Blah, blah, blah. Let's do admin. Okay, oh, the microphone has to move. This is the issue. Okay. Now, okay, so now you didn't see the spinner because we already know the validation is either failing or passing to begin with, so we don't have to do anything else because it's already memoized. But now I remove everything. I'll remove everything from that field, and you'll see this the beach ball, even though we know it's failing to begin with. Why should we show the spinner? Why should we go to the server for an empty username? And you are right. And let's change and let's add the eager mode. Move. Okay. Let's do skip when. Skip when. Let's tell Vest, well, I know when I should be running the field and when I should not be running that test for the field. So let's do skip when, and basically it tells me, yeah, you can skip the validation for a certain field whenever something happens. Okay. All I need to say, and this is going to be the last time I use the microphone like this, but all I need to do here is just say, well, if suite.get, remember the original state for the form, if the suite.get has errors for username, yeah, don't go ahead to the server to begin with. You shouldn't go to the server. So let's try this. I'm typing one character. We're not seeing the spinner because it's failing. I'm typing again. Yeah, we're seeing the beach ball. Everything works perfectly. And just see this. It tells you exactly what is being validated, how many validation are there. You don't make any change to the form itself, to the feature logic, in order to make additions to it. You have 2 rows on each element and some class names, and basically that's it. That's all you have to add in order to use Vest in your apps. And now I'm going to go back to the presentation because I'm done with the live coding bit. By the way, it went better than I expected. And thank you. And let's see. So these are some of Vest's features. You've seen many of them, not all of them. We have validation, change, blah, blah, blah. We can validate fields upon user interaction. We have multiple validations per field because you've seen we had 3 different tests for username. This is really hard to do anywhere else. We are framework agnostic. We have inner scopes like describes, inner describes inside a group. We have async validations. We can memorize them and many, many, many more. It's working really well. I'm working very hard also to maintain it. We're in version 4 at the moment. You can install it. It's just 7 kilobytes, I think, when minizipped. So not a big overhead to your app. And if you add many forms, well, this is even going to pay for itself. There's a documentation website. You can find me on the GitHub profile. vestjs.dev is the documentation. And also Twitter. Ask me anything.
Bravo.